myself Suguna, Assistant Professor, GFGC and PG Center, Chintamani, Chikkaballapur District. In this session, I am going to teach you how to trace Cartesian curves. See, tracing of curves is very useful in engineering and also to find the surface area and volume of the curved surfaces. Trace the curve y square into a minus x is equal to x cube, where a is always a positive one. So this problem we will take, and this curve is known as cissoid of Diocles. Cissoid of Diocles. The equation of the curve contains only even powers of y. Even powers of y. That is y square. Therefore, it is symmetrical about x-axis. It is symmetrical about x-axis. So, point 1 is traced. That is, it is symmetrical about x-axis. Now, point 2. Let us find the point of intersection of the curve with the x and y axis. Now, we will put x is equal to 0 and y is equal to 0 in this equation. Okay, this is the given curve. Put x is equal to 0. When x is equal to 0, y square into a minus 0 is equal to 0. What does it imply? Y is equal to 0. Y square into a is equal to 0 means y is equal to 0. Similarly, put y is equal to 0. Then you will get 0 into a minus x is equal to x cube. So 0 is equal to x cube. So this also implies x is equal to 0. See, when x is equal to 0, y is 0, and when y is equal to 0, x is also 0. Right? So which implies that when x is equal to 0, implies y is equal to 0. Similarly, when y is equal to 0, implies x is equal to 0. So what is the point of intersection here? The point of intersection here is 0, 0. Right? So it is the origin, which implies that 0, 0 is the point of intersection. Point of intersection, which is nothing but the origin. This also can be checked by the given equation. See, the given equation does not contain the constant term. There is no independent constant term in the equation. So, origin is the only point of intersection. See, the given equation of the curve does not contain constant term. Therefore, origin is the only point of intersection. Means the curve meets only at the origin. So that we can write in a simple manner. Origin is the only point of intersection. By equating the coefficient of highest degree term of y is equal to 0, we get what is the coefficient of highest degree term? A minus x. A minus x is equal to 0 implies that a is equal to x. A is equal to x is the asymptote parallel to y axis. It is the asymptote parallel to y axis. And take the highest degree term of x, that is x cube. x cube coefficient is 1. So there is no asymptote parallel to x axis. Okay. So this is the only asymptote parallel to y axis. Now, fourth point. We have to find the nature of the double points. So to find the nature of the double points, we must know the tangent, right? So to know the tangent, let us equate the lowest degree terms to 0 and we get the equation of the tangent at 0, 0. Okay. So in the equation, the lowest degree term is equate the lowest degree term to 0. So to get the nature of the double point, so which implies that y square into a minus x is equal to 0. This is the lowest degree term, which implies that y square is equal to 0 or y is equal to 0. Y is equal to 0. Thus, it implies that we get the equation of the tangent at 0, 0. See, 0 and we get tangent. See, when you equate this to 0, lowest degree term to 0, we get the tangent at 0, 0. Because 0 is the point of intersection, we know. Now, when we equate the lowest degree term to 0, we get y is equal to 0. Thus, the two tangents, see, it should have two tangents. Y square is equal to 0 means two values we should get. But single value we are getting. That implies that the two tangents are coincident. The two tangents are real and see real value we got. It's not imaginary value. Real and coincident. Real and coincident. Right. So when do we have the real and coincident tangents? When the given point is a cusp. So this implies that it is a cusp. When the tangents are real and coincident, then the origin is a cusp. This is the only point. So it is a cusp means it is nothing but the origin is a cusp. Therefore, the origin is a cusp. Okay. See, the curve starts at the origin and that origin is a cusp. Then, point 5 required is, see, we found out the nature of the double points and also asymptotes. Next, whether the curve is increasing or decreasing, we should find. Okay. Now, let us consider the given curve and equate it to y. Point 5. Take y square into a minus x is equal to x cube and equate this to y. So you will get y square is equal to x cube by a minus x. Now we want only y. So which is plus or minus square root of x cube by a minus x. And here x should not be equal to a. If x is equal to a, it becomes indeterminate. Right? Now let us remove the square root of this. See, we get y is equal to x square into x is the x cube. So one x can be removed outside. So which is x by a minus x. Y is equal to plus or minus x root of x by a minus x. Taking the only positive sign. So we will take positive, only positive sign. Only positive sign, we get y is equal to x into root of x by a minus x. We will consider only positive value. Then y will be equal to root of x by a minus x. Okay. If the value of x is greater than a, if the value of x is greater than a, what will be the answer? If it is greater than a, then you will get a negative term. Root of negative term is imaginary. Root of negative term is imaginary. See, if x is greater than a, then y is imaginary. Y is imaginary. Since y is imaginary, then we know that the curve does not lie to the left of the y-axis, okay, and to the right of the line x is equal to a. To x is equal to a, to right of that line and left of that line it won't exist. Okay, thus the curve does not lie to the left of the y-axis. Left of the y-axis and left of the y-axis and right to the line x is equal to a. Right to the line x is equal to a. Now we got the idea that where the curve exactly lies. See, it won't lie at the left side of the y-axis. See, suppose if you take y and x-axis. See, this is the left side. So the curve lies only in this area, not left of the x-axis. And x is equal to a means somewhere you will get a line x is equal to a. Does not go beyond that, right side of that. So the curve is inside of these two limits. So the curve does not lie left to the y-axis and right to the line x is equal to a. So 5 points over. Then the last point is 6 point. 6 point means here we are going to find the region in which the curve is decreasing and increasing. Okay. Now to find out this, we have to find the derivative of the given curve. See, let us take the given curve as y square is equal to x cube by a minus x. I have transferred x terms to one side in the given equation. So differentiate this both sides with respect to x. So you get 2y dy by dx left side is equal to, for this we have to use the quotient rule. So quotient rule is a minus x into derivative of x cube is 3x square minus, so we have x cube right as it is, into derivative of a minus x is minus 1 divided by a minus x whole square. Okay. So this we will equate to dy by dx. So we get dy by dx is equal to 2y will transfer this side and simplify these terms. So we will multiply together and simplify 3x square a minus 3x cube minus into minus plus x cube by a minus x whole square into, see this 2y I am transferring to this side, so it becomes 1 by 2y. 1 by 2y. So further simplifying this, I get dy by dx is equal to, see, 1 by, I will take the values and simplify here. Dy by dx is equal to 1 by 2 into root of x by a minus x, total simplified term it is, into 3ax square minus 3x cube plus x cube, it is minus 2x cube by a minus x whole square. See here, this y value I have substituted here, that is 2 into y value is x by, that is a by a minus x. Okay, so 2y value I have substituted, that is x cube by root of a minus x. Okay, then see this value, always it is greater than 0 for x is a line between 0 to a. X is line between 0 to a. See, when you put x is equal to 0, then you will get the values here, that is 1 by 0 and these things, and simplifying always we get this as a positive value. Okay, so the curve is increasing. The curve is increasing in this area. See, this implies that dy by dx is always greater than 0. Always greater than 0. See, when dy by dx is greater than 0, which implies that y is increasing. Y is increasing. In the region x varies from 0 to a. In the x varies from 0 to a, y is increasing. Now, let me trace this curve by using these factors. Right? So, I will use this area for this. Now, first point, we will draw the x coordinate axis, x and y, x O, x dash, y O, y dash. Now, we observe the curve is symmetrical about the x axis. Curve is symmetrical about the x axis. Then, the point of intersection is 0. Point 2, the point of intersection is 0, 0 is the point of intersection. Then, the asymptote parallel to y-axis we got, that is x is equal to a. X is equal to a is this line. Right? This is the asymptote. I have drawn the asymptote. Then, the nature of the point, it is a cusp. It is a cusp. Cusp means from here the curve starts like this. And from the fifth point we know that it does not lie left to the y-axis and it does not go beyond the x is equal to a. Okay. So the curve is increasing in this axis, that we know. Dy by dx is positive. So along the y-axis it is increasing. See, this is the required curve. This is the required curve. See, like this we trace the different types of curves by using the data of how to trace the Cartesian curves. So by using that we can trace any equation of the curve is given. You can trace the given curve by using this data. Okay, so first we should find the symmetry of the curve and the points of intersection, then this one asymptotes, then nature of the double point, then where the curve lies and where it is increasing and decreasing. By considering these 6 points, we can trace the given curve. Thank you.